Hello and welcome back, guys. So in this particular session what we'll be discussing about is the question has asked us two cards are drawn from a well shuffled deck of 52 cards. Find the probability both the cards are king. First card is not replaced by drawing a T diagram, right? So it's not being replaced, and also what's the probability of getting two kings, right, in a deck. So let's think of it from a gambler's perspective. Okay, so let's assume that K is the king and O is the other cards. Okay, so what will be your probability for getting king from a deck of card will be 52. You'll have 4 kings, right? So it will basically be 1 by 13, right? And then in this case as well it will be 48 by 52. Okay, so basically 48 divided by 52, 12 by 13. So again, when you're drawing it back again, what you'll have is basically, first of all you'll have 4 and 48, so you'll have 4 kings and then 48 other cards. That will make it total to 52, right? So whereas in this particular case what will happen is your number will go down. It will be 51 only, because you have already drawn. So suppose the in the first draw you got king, right? So we'll only have how many kings left? 3 kings left, 48 of the others left, right? So your probability of getting a king will be, this will also decrease, the total number of sample will also decrease. Okay, and then your other cards will be, it will be same 48, but your total sample will decrease, right? So if the draw was if when you pulled the first card it was maybe other cards than the king, right? So what's your probability of getting king then after that? So let's look at it as well. So 4 king is already there because king has not been pulled out in the first draw. That means you'd have other cards which is O remaining, right? So how many of them will be remaining? Since one will be pulled out, that means 47 will be remaining, right? So when you add it up you'll get 51. Okay, 51. And then what will be your probability of getting king? It will still be 4. Okay, the number of kings will still be 4. It won't be reduced because the king has not been pulled in the first attempt. Okay, after that you will also have to figure out for the O as well. So since in your first attempt you were basically from the deck of cards which were other than the king, you had already pulled one out, right? So you'll only have 47 of them remaining. Okay, so that will be your probability. Okay, so your probability of getting king comma king will be 1 by 13 into 3 by 51, right? The question asks this particular thing itself. So it will be 3 and then 13 into 51, 663. So where did I make a mistake? Okay, let's do it one more time. Okay, so 12 divided by 52 into 51, 1 by 221. So where did I mess it up? Okay, this should be 6, 221. No, it should be more. So 3 divided by 16 into 51, right? 16 into 51, 816. 3 divided by 816. What the hell? Anyways, you can just do it this way as well. Okay, you'll get 1 divided by 221. Okay, so what will be the probability for this? K comma O. 4 by 52 into 48 divided by 51, right? In this case as well, okay, 48 divided by 52 into 4 divided by 51. In this case you will be getting a probability of something of this sort. Okay, So yeah, our probability is 1 by 221. So that will be our getting the probability of this sort of card, right? So if the question asks you again, so what's the probability of getting not kings, right? So what will happen is basically a list of them. Okay, so if there is non kings, so probability of not getting no king, right? So what will that be? Basically it's trying to say this probability over here. Okay, so all we do is we just bring this particular number over here and then solve it. That will be our answer. Okay, whereas if the question asks us if there is at least two kings, then what we do is that basically we add this and this up like the other ones that we had done earlier, right? That's how we solve it. Okay, so whether it's being replaced or not, and then what does the requirement say, that's what we need to figure out. Okay, so if you have any confusions regarding this particular question or any other questions that you are trying to do, please do comment down below. I'll definitely be happy to answer it for you. Until next time, bye bye.